Hello, and welcome to this session of Working Efficiently with Oracle. In today's session, we will be focusing on the Oracle architecture. The audience for this session is the Oracle Database Administrator, who typically manages Oracle databases in an organization.
This slide shows you the series objective as to what we want to accomplish through these tutorials. What is being covered in this session? We have divided this architecture into three different sessions. So this is the first session, which talks about the architecture overview and which focuses on the physical and logical structures. The second session would be focusing on the memory structures, and the third session would focus on the background processes. The first question that people typically ask is, why Oracle architecture? Why is it important to know more about how the Oracle database functions? Now, from a database administrator perspective, most DBAs would definitely agree that architecture would play a primary role with respect to all their day-to-day activities. So without the architecture, the DBA is almost handicapped when it comes to just working with tools and with commands. So it's essential that the DBA knows architecture. And in my experience, I have seen that when you talk about the Oracle database administration, it's almost 70% concepts and 30% application of those concepts. So the architecture plays a very important role when it comes to learning the concepts. So moving on, we're going to get into the architectural overview. So when we look at it from, let's say, a 20,000 feet perspective, the Oracle architecture comprises only of two components. You have a database and you have an instance. A database is a set of files which are on the database server, and instance is a set of memory structures and accompanying background processes using which you can access the data in the database. So let's first get on to the database part of it. Now there are multiple taxonomies that are used to describe the database, but the more prominent ones are talking about them in terms of physical structures and logical structures. When we use the term physical structures, we're talking about files which can be seen at an OS level. So if you're a Unix or a Linux administrator working in those platforms, then you will see those files in the mount points. You probably do an ls-l to see all this information. But on the other hand, if you're working in a Windows environment, then you go to Explorer and you view these files. Now, in case ASM is being used, ASM meaning automatic storage management is being used, then all these files are stored within ASM. In that scenario, you will not be able to see this directly from the OS, but you can definitely get within ASM and then you can have a look at these files. So when we talk about the files, again, we kind of classify them into database files and additional files. Now, the database files are the core files which form the database, which are main components of the database. So here we are talking about the data files, the control files, the temporary files, the reader log files, and the parameter file. Now, data files basically are used to store the data. So this is the data that is stored through applications and retrieved and manipulated, and so many other functions happen on this data. Control files store metadata about the database itself, but this is more from a critical perspective, and control files are typically used by the database for critical activities. So it would be safe to say that without the control file, your database cannot be operational and running. So it's a good idea to multiplex the control files, but we will talk about control files a little later in the session. If you are doing a lot of sorting, then you would need the temp files. The temp files are typically files which are used for storing temporary segments. Temporary segments are those segments which are allocated when Oracle needs them to do a sorting requested by a user. Then you have reader log files. We will talk about this in detail, but in short, redo log files capture all the changes that are made to the Oracle database. And finally, there is a parameter file. Now, there are two types of parameter files. One is a normal parameter file. The other one is called a server parameter file. The difference is that the normal parameter file is, it's editable, and you can manipulate it. On the other hand, the server parameter file, or the SP file, uh, is a kind of binary file, which is used in the same way as the normal parameter file, and any change that has to be made to a parameter can be done through the SQL plus command, directly on the SP file, and those changes immediately take place or take effect. Now, apart from these, you have some additional files. You have trace files. Now, every background process generates a trace file, especially when there is an unexpected event. So Oracle raises a trace file which actually captures the happenings around the event. Now, trace files are very useful when you have to debug any issue, and in most cases, they are used by Oracle's support team to help you troubleshoot your database issue. You also have the password files. The password file being a file that is used typically when you want people to sign in as a super user from either the same system or from a different system. Then you have the alert file. The alert file is a text file which is capturing information about the main happenings of the database. It's also a very good starting point for a DBA to find out if there's a problem that's brewing up within the database. And finally, log files. Now, these log files are associated with the tools that come with the Oracle, the executables. So whenever the executable is doing certain things, it captures some of its activities and stores them as log files. Now, as I said, the same set of database files can also be stored inside the automatic storage management, the ASM path, if you're adopting that. And ASM, actually offers a lot of benefits compared to a normal operating system. And when you talk about ASM, ASM is all about managing raw disks. So Oracle takes the raw disk, it manages it, and it stores all this information, and it ensures that IO is uniformly distributed across the ASM disk, and we don't have to worry about IO tuning to a greater extent as in previous versions. Moving on to the next slide, we talk about the database files. So these are the various database files that are available. You have the data file, you have the control file, you have the redo log files, you have the temp file, and you have the parameter file. Now please note that all these files can be placed within ASM. All these files can be placed within ASM, including the parameter file. So moving on to the next slide, we have the data files. We'll talk about the data files here. Purpose of data files is to store all the data that your application generates or your application accepts. So ultimately, the data that you want to query, the data that you want to manipulate, the data you want to modify, everything is actually within the data file. When we talk about data files, you have two types of data files. One is the permanent data files, which is typically used to store table data, index data, and so on and so forth. And then you have a temporary data file, which is basically used by the temporary table space of the database. So when you create a table space with data type as temp, basically you do that using creating a temporary table space. When you do that, temporary segments are created in that particular table space. We'll get quickly to what segments are in a couple of minutes. But just note that temporary information is stored in temporary files and permanent information is stored in permanent files, persistent information. Now, the data file structure is pretty straightforward. I mean, it's in a binary format which can be understood only by the Oracle software and code. And every data file has a header which talks more about the contents of the data file. It talks about the SCN number. The SCN number is something that most DBAs would be aware of. It's also called the system change number. It's basically a tracking number, and it also captures a timestamp, so as to when the latest information was returned to the data file from the buffers. But again, those are all things that we will look at in greater depth a little later. So moving on, we move on to what a control file is. A control file actually stores information which is very critical for the functioning of a database. Apart from a lot of other things, the control file also contains information about the database, its ID, the various table spaces which make up the database, the timestamp of the last checkpoint. It also has information about the online logs, the archive logs, and what table spaces are there. And in case you're running a database, running a database backups using RMAN, then the control file also has the RMAN related information in it, especially when you're running it without a recovery catalog. So the control file captures a lot of useful information, and this useful information is typically used by the database very frequently. So it's always a best practice to multiplex a control file, and also to note that when a database starts up, there's an initialization parameter file that's used. The initialization parameter file just gives the location of the control file, and once the control file is read, I mean, it's only from the control file that the database knows the location, the number of table spaces, and the number and location of the data files, and then it opens the database. So you can understand how important it is to have the control file. Again, within a control file, there are certain parts which are circular and with certain parts which are non-circular. So circular parts of the control file are rewritten with newer information, but non-circular parts are not rewritten and they rarely change. Moving on to the redo log file. The redo log file actually captures all the changes made to the database. So when we say changes made to the database, in simple terms, we use the term a redo record. So redo logs actually capture redo record. So for example, let's say a particular session is updating a row in a table. So there would typically be 3 redo records which would be generated for this single atomic transaction. The first redo record would be generated because the data in the destination table is changing for the single row. So there would be a change vector that is created for that activity. Second, because the row has been updated, there is an undo image that is created. Now, undo image is nothing but the pre-image of the data block before it was modified. So the pre-image of that particular row before it was modified, that's what is the undo image. So there would be a second redo record that's created for that particular purpose, or change vector that's created for that particular purpose. And this information is tracked inside the transaction table of an undo segment. So the undo segment would have a transaction table in its header where it stores information as to the location of the modified data and the location of the old data. So there would be a third change vector which is generated. So all these 3 change vectors that we spoke about, the first one being for the table block, second one being for the undo segment, and third one being for the transaction table, all of these are taken together and stored as a redo record in the redo log file. Initially, they are stored in the log buffer, but there is a process called as the log writer, which actually moves the content of the log buffer back into the redo log files. Now, redo log files operate in a circular fashion. Having said that, it means that there are a minimum of two redo log file groups associated with any database. And the way they work is the moment the first redo log file is written completely, the control moves on to the second redo log file, and the second redo log file is written. And at the end of the second redo log file, the control goes back to the first redo log file. So that is if you have only two groups. Now, again, as a best practice, it's always recommended to multiplex redo log files as well. So that's pretty much what is present in a redo log file in terms of its usage. And if you look at the structure, the change vector, the redo record, I mean, it contains a lot of information, which obviously is useful for recovery purpose or restoration purpose, as in the case of a standby database. It contains the SCN and the timestamp of the change as it is happening. It contains the transaction ID of the transaction which actually did the change. In case there was a commit, then the SCN and the timestamp of that particular commit associated with the transaction, and what kind of an operation it was which we made the change, whether it was an insert, update, delete, or truncate, anything. And finally, the name and the type of the modified data segment. So basically, this information is used to replay all the activities happening within a database in the event of a database crash. So as you can see, the redo log file plays a very prominent role. It works on a round robin fashion when data is being written to the redo log file by the log writer process from the log buffer, and it is a very useful structure when it comes to the Oracle database. Now there are the additional files, which is something we spoke about. We have the trace files, we have the password files, we have the alert files, and the log files. We come to logical structures. These are the structures that you see when you log into the database. So the physical structures are the ones that we saw from outside the database, from an OS perspective, and the logical structures are those that we are seeing from within a database. So within a database, the biggest object that you will see is that of a table space. Now, a table space is mapped to a physical data file. So please note that a table space can be mapped to one or more physical data files, but the vice versa is not possible. That is, a single data file cannot belong to more than one table space. Now, within a table space, you have segments. Now, segments for us in simple terms are the objects which map to tables, indexes, undo segments, and all. So there are prominently four types of segments that we come across. You have the data segment, which is the associated with the table. We have the index segment, which is associated with the indexes, which consists of the index entries. Then you have the temporary segment, which actually is with the temporary table space. And finally, you have the undo segment. Undo segment is with the rollback and the undo table spaces. Apart from this, there is also a bootstrap segment, but that is operational only when the database is being brought up, is the instance is being started. Now, please note that a segment can span multiple data files within a table space. Now, a segment consists of an extent, and a segment can have multiple extents. So each of these extents could come from different data files, or they could all be in the same data file. Now, please note that the extent is the minimum IO allocation unit when it comes to an Oracle database. So it means to say that when you are requesting additional space for your table or your index, Oracle is going to allocate it based on the extents. And extents internally comprise of continuous data blocks. We just call them as DB blocks or data blocks. So an extent consists of a set of continuous blocks. So if an extent is supposed to have four blocks, then it means that all these four blocks are present one after the other in the data file. So I do hope you have understood whatever we have tried to cover so far in this session. This is the first session on the Oracle architecture part. We will have further sessions coming up soon, which talk about the memory structures and the background process. Happy learning.